All right. Welcome, everybody, to the next monthly Ceph Tech Talk, where we try to feature some of the inner workings of Ceph at a deep technical exploration level so that we can enhance the greater technical understanding of Ceph. In the past, we've looked at RADOS and the block device and the gateway, as well as the Calamari API and all GUI associated things. This month, we have an examination of placement groups by a longtime friend and supporter of the Ceph community, Florian Haas from Hastexo. Florian, would you like to go ahead and introduce yourself and get rolling?
Absolutely. Thank you, Patrick. Good afternoon, good morning, or good evening, depending on wherever you are. And welcome to this Ceph Tech Talk. As Patrick has introduced me, my name is Florian. I'm from Hastexo. We are a professional services company that, among other things, offers consulting and training services around Ceph. And when Patrick invited me to do a tech talk here, one of the things that I wanted to talk about were essentially sort of the ins and outs of placement groups. Because, as I found out, it's one of those things that kind of confound people about Ceph, as in what are they actually good for and what can we do with them. So this tech talk is called Ceph Placement Groups Inside and Out, and we'll get started straight away. So let's talk about data placement for a moment, and let's diverge or sort of go off on a tangent here for a little bit. What does data placement and conventional data lookup look like in legacy distributed storage systems? So the way that this typically works in a conventional fashion in a legacy system, very much unlike Ceph, is this way. You talk to a central lookup service to find out where you need to write your data or where you need to read your data from. And then you take that information and you go to your storage servers and talk to them directly. That's sort of a standard legacy method of doing things. Now, what Ceph wants to do, however, is it wants to actually scale this to potentially thousands of storage locations and petabytes and exabytes of data. So how does a central lookup work in terms of actual horizontal scalability? To what extent does it actually provide horizontal scalability to that petabyte and exabyte scale level? Actually, it doesn't. It doesn't work. That sort of thing really doesn't work because your central lookup facility always becomes a bottleneck and a single point of failure. That's not what Ceph wants to do. So instead, the idea in Ceph is that you don't actually look up where data is, but you have every single component in the system, including clients, including servers, actually work out where they can find their data. So that's a standard feature sort of Ceph, but how do placement groups actually come in? Why do we need placement groups? What are they good for? And what is their specific role? Now, there's two ways of explaining this. One is a very abstract way where you talk about objects and data storage locations and a storage topology and things like that. But I find that very opaque, and I don't really, like to explain it in those terms. So I'd like to use a metaphor, and I call it the parable of the tennis coach, or more precisely, the parable of the obsessive-compulsive tennis coach. So bear with me for a moment while you imagine that I'm a tennis coach that has a little bit of an OCD problem. And it's the first day of summer tennis camp, and I walk onto the court, and I've got 5 students, Alice, Bob, Charlie, Daisy, and Eric, and I have 300 tennis balls that I want to distribute among them. And I want to distribute them evenly, so every single one has the same number of tennis balls. Well, how can I do that? I can use something very, very simple and naive, but something that actually works, is I could use a round-robin approach, which means I reach into this shopping cart of 300 tennis balls, and I chuck the first one to my first student, and the second one to my second student, all the way to the fifth, and then I start over at the beginning. And when I'm done with that, then I'm going to have my tennis balls, my data, distributed evenly among my storage locations, my students. Well, but actually my OCD isn't quite happy with that, because what I really want to do is I want to distribute these tennis balls reproducibly. In other words, I want to be able to look at a specific tennis ball and know exactly where it needs to go. I want to, and when I see a ball lying around on the ground on the court, I want to be able to pick it up and know exactly which of my students it belongs to. So what can I do in order to achieve that and to make this sort of round-robin thing more reproducible? Well, I just take a Sharpie and I number all of my tennis balls. I number them from 0 to 299, and then I apply a very simple algorithm to distribute them. And that simple algorithm that I can use is just effectively division and a modulo algorithm. So I can randomly pick up the ball with the number 130, divide by 5, remainder is 0. It goes to my first student, Alice. I pick up another one, 71. Divide by 5, remainder is 1. It goes to Bob. I pick up another ball randomly. It has the number 213. Divide by 5, remainder is 3. And it goes to Daisy. So I'm happy. I have found and devised a way of simply and reproducibly distributing my data, all of it, until disaster strikes. Something terrible happens. At 9:30 in the morning, I have a 6th student walk onto my court. Frankie slept in and is kind of still a little dazed and confused, and now walks onto my tennis court. And now I have a 6th student, and now what do? Uh-oh. Well, I figure that maybe, we're not doing that badly, because as it happens, I pick up a ball randomly. It has the number 31. I divide by 5, remainder is 1. I divide remainder is also 1, so it stays with Bob, and I think we're kind of cool. But of course, that doesn't last long, because I pick up another one. It happens to have the number 36, and now the remainders are different. And now I realize that by the simple modification, namely I have one additional student, I now need to shuffle around tennis balls between all of my students, and I need to do some shuffling around that actually doesn't involve Frankie, my new student, at all. As you see in this example, I have a ball that's going from Bob to Alice and so forth. So that naive approach doesn't really work. Now, as it happens, what that means is that we get a change in capacity. In this case, a number of students that changes, and the number of tennis balls that I need to shuffle around is totally out of whack with the actual change in capacity. So what I'm creating with this simple and naive approach is I get something that distributes very evenly, but that creates an insane amount of migration if there is the slightest change to the system. And this is a problem that every distributed storage system has. Every distributed storage system wants to distribute data evenly, but it also wants to create a configuration that has minimal migration when capacity changes. And just about every contemporary distributed storage system solves it effectively the same way. In Ceph, it's called placement groups. In Swift, they're called partitions, and so forth. So how does this work? What do? Well, it's actually fairly simple, and that is we add an additional management layer. And in the tennis court or tennis camp analogy, it's just a set of buckets that we can put our tennis balls into. So suppose we've got 60 of them. I've got 60 buckets. We use exactly the same algorithm, except that we now use a different operand for that modulo division. So I can pick up a ball number 130. I get a certain remainder. It goes into a specific bucket. And I do that with others as well. And I can uniquely assign them to, or I can clearly and reproducibly assign them to a specific bucket. And now we keep a list of all the buckets for every student, and we make that list available to everyone. Every one of my students gets a list, and I have that list. So the only thing that we now need to do is, the original situation was we distributed the buckets among the 5 students, and now if Frankie walks onto the court late, we only move a handful of buckets and update the list. So what happens is everyone just gives up 2 of their 12 buckets that they previously had, and everyone ends up having 10. And suddenly we have devised a system where the migration is proportional to the capacity change, which is exactly what we want. And now if we just translate all of that into Ceph terminology, the analogy becomes hopefully very, very clear in that the tennis balls that we're talking to map directly to our RADOS objects. The numerical IDs that I sharpie onto the tennis balls translate to the object hashes that Ceph uses as internal unique object identifier. The buckets that we have are our placement groups. The students are Ceph OSDs. And the list, which is effectively a set of parameters to this very simple algorithm that we're using, translates to the Ceph OSD map. And now it's important to understand that this map, the parameters to our algorithm, that changes only when our storage topology changes. If we remove a storage location or add a new one, that's when we need to update the map. And that map is lazily propagated throughout the system. And on the whole, what we get is something that is much more effective, much more efficient, and much more scalable than central data lookups. And that's really the whole story, why we need placement groups in the first place. They are a very, very simple addition to an otherwise very, very simple algorithm, but it's kind of simple but genius. One thing that I didn't mention previously is the fact that typically what you shoot for, and again, this is true for Ceph, but it's also true for other distributed storage systems, is that the number of buckets that you have in the system, the number of placement groups, is 1 to 2 orders of magnitude larger than the number of actual physical storage locations, which is what you also got with the 5 to 6 students and the 60 buckets. And the reason for that is, of course, that you want to be able to redistribute them accordingly and at best avoid the situation where you actually need to split buckets, because that's an operation that's expensive. So this is why we need placement groups. This is why we have them in Ceph. So what can we do with them? Well, we should look first at how we can actually examine placement groups and their status. The way that you're probably going to do that initially, most of the time, or very frequently, is with the Ceph health command. So let me run you through this here real quickly. So what I'm doing here is, there we go. That is taking a little longer than expected, so let me just reload that here. We should be fine. Oh. What's going on here? Sorry about that. See, this is why you rehearse. And you still have a demo effect. Yes. Okay, so let's see if this works better now. There we go. Okay, so let me put that on full screen again. Okay, so if you do a Ceph health command and everything's fine, you're just going to get a health OK back. And what I'm doing here is I'm taking one of my storage locations, one of my OSDs out of the system. If you now do a Ceph health, you get the health warn. And then if you do your Ceph health detail, what you're getting back is a list of all of the placement groups in the system and their current status. I'm sorry, not all the placement groups, but only the ones that are not in the active and clean state, the ones that are currently affected by some sort of outage. So what you're seeing here is I have a handful of placement groups that are currently in the active and degraded state because I took one of my OSDs out, and we're going to go over the various PG states in just a moment. Now, if I put my OSD back in to action, so there we go, that's my OSD that I'm restarting, then my previously degraded placement groups are going to go into recovery state, as you can see here, and then it takes just a little while, and then we get back to the health OK state. So that's the first way of getting a handle on the status of your placement group, is simply the Ceph health command. And if you want to get a little more information, then you can use Ceph pgdump. So let's take a look at what Ceph pgdump does for us. Ceph pgdump simply gives us a tabular overview over all of our placement groups. And what I've done here at the bottom, because it's a fair amount of it's a fair screen full here, is I've taken out a quick grep for one specific placement group ID. So let me quickly walk you through the output that you get here. You get, as I said, a tabular output that starts with the placement group ID, and then it gives us various bits of information, such as what is the current placement group state. In this case, it's active and clean. When was the state last updated? And also, what are the current replicas that this placement group is assigned to. And you can see here there's a list 0 and 5, so that means it's assigned to OSDs 0 and 5. From this you can deduce that this is a pool with a size of 2, so 2 replicas for every object, and then 0 is the primary OSD for this placement group. Ceph pgdump is a fairly helpful command if you just want to get a little bit of extra information about either, well, all of your placement groups, or just a specific one if you add that grep. If you want to get a little more information, you can do that as well. And there is the Ceph pg query command. Now, I found out that while this command is perfectly documented in the Ceph documentation. It apparently is not known to that many people, so I want to make a point of mentioning it here. So the syntax for that is cephpg followed by a placement group ID and then the keyword query, as you can see at the top of the screen here. And then you get a JSON output of pretty much everything that Ceph knows about this PG, such as when was it last clean, when was it last unstale, when did the last scrub or deep scrub run, and a bunch of other information. And we're going to come back to that in a little bit because it has one very crucial bit of information in it in a specific error state. So that's cephpg query. And then finally, every once in a while, you may want to find out what placement group a specific object belongs to in the first place. And that you can do very simply with Ceph OSD map. Let's take a look at the Ceph OSD map command here real quickly. What I'm doing here is I'm simply enumerating RADOS objects in a specific pool, and then I'm mapping one object in this pool. And the syntax for that is Ceph OSD map followed by the pool name followed by the object name, and then what we get back is the PG that this object belongs to and what the current replica set is for this object and the primary OSD for it as well. So what you get here is OSD 7 and 4, and the primary is OSD 7. So those are kind of the most frequently used commands if you want to query a placement group's status. And one of the most important bits of information that you can get out of this, both out of cephpg dump and also cephpg query, is the placement group state or placement group status. So what's in there, and what are the typical states or typical statuses that you can find? So the normal state that we have in a placement group is called active and clean. So what does this mean? It means that the placement group is currently available to process requests. That is to say, we can read from it and we can write to it. That is the active bit, and the clean bit means that for this placement group, we currently have the correct number of replicas available. So if it is a placement group in a pool with a size of, say, 3, then we would have that if we currently have 3 replicas available. If we have a placement group that is currently in a degraded state, then that simply means that that placement group currently has fewer replicas available than are mandated by its pool size. So in other words, for example, we have a pool size of 3 and we only have 2 replicas available. So what should you do in this case? Well, most of the time, actually nothing. So typically, no action is needed in this state. You will either run to recovery, which will commence when the OSD either comes back or when its mono-OSD down-out interval, by default 5 minutes, expires. And in that case, Ceph will then assign a new OSD to the placement group and recovery will commence from there. So a degraded state is basically nothing particularly to worry about. It simply means that one of your OSDs is currently down, but the placement group and the data in it are still perfectly available. If an OSD has previously gone down and it comes back up, then it is catching up from its previously degraded state, and that is a state that we call recovering. And that simply means that the 2 replicas, or the replicas that you have, are being brought back into sync from an out-of-sync state. There's a sort of special case for that, and that's called a backfill. And if your PG is backfilling, it's roughly doing the same thing as recovering, but it's starting from an empty set, from an empty replica. This, for example, is the case when you add new OSDs and data is being reassigned, or your previously up and in OSD has gone down, has subsequently been marked out. Ceph has selected a new replica on a different OSD for a specific placement group and is now backfilling, meaning filling the OSD, the new OSD, with the data in that placement group. Then we have an incomplete state. Now that's a little bit of it's a more tricky one. That's actually a warning state, and that means that in a specific placement group, we have fewer replicas available than are mandated by the pool's minimum size, the pool min size parameter. So for example, if you have a pool min size of 2 and you only have one replica available, then that PG would be marked incomplete. So what can you do in order to recover from that? Well, if you have a PG stuck in this state, it basically means that Ceph cannot fulfill the redundancy guarantees that you've defined for the pool given the current crush map. So what you might need to do is you either want to bring up another OSD so that the consistency or the replication guarantees can be fulfilled, or you make a change to the crush map. However, that's a big beware there, because you should take into account that if you make a crush map change, it might trigger some or potentially a lot of reshuffling that you actually don't want at this point. Or another thing that you can do, at least temporarily, is change the min size of that specific pool and then bring it back up to the previous min size later in order to get out of the incomplete state. But the best way is to just find another OSD that Ceph can replicate to, by default at least. If a placement group is inconsistent, then that means that you've previously run a scrub or a deep scrub operation on the placement group, and it has detected errors. Now, if the errors were detected immediately from the file's metadata in the OSD, and that is something that a scrub would catch. If you have files in there that have the correct size and correct metadata and whatnot, but don't have the content in there that Ceph expects, for example, due to bit drop, then that is something that a deep scrub would detect. Either way, the PG would go to the inconsistent state, and what you do in order to recover from that is you run a Ceph PG repair on that placement group. Finally, the down state. Now, this is one where you have critical data missing and the PG is therefore unavailable. How do you get yourself into this state? Consider, for example, you have a pool with a size of 2, so 2 replicas for every object. You have one of your PGs, one of your replicas going down, then you modify the other one, then that one goes down as well, and you bring the original one back up. Then that one has data that is actually stale. That is, if it were to become active, it would warp you back in time. And so therefore, by default, Ceph will disallow that, will mark the PG down, and that means that you actually can't do any IO to that placement group. The way that you recover from that is you either need to bring one of the other OSDs back, namely the one that actually has the last good data, or if you cannot do that for some reason, so such as, for example, you had a catastrophic failure and the OSD actually lost its disk physically or whichever, then you also have the option to declare the OSD lost. Again, beware, this is a potentially destructive operation because you may lose the most recent updates to some of your data. And here's where we come back to the PG query from earlier, because the question, of course, is always, okay, which is the OSD that I need to bring back, or which is the one that I need to declare lost in order to get this placement group back up? And this is something that you also find out with Ceph PG query. When a placement group is down, then in the JSON that Ceph PG query produces, you're going to see an entry that's called down OSDs we would probe, and that's the OSD that you need to be looking for and that you then subsequently need to recover or declare lost. Again, as a caveat, if you declare an OSD lost, and this is actually very well documented in the Ceph documentation, you will potentially lose some data because you might lose the last updates that you've seen on one of your OSDs. Okay, so that basically concludes my little 3-part talk about placement groups, what they're good for, how we can get their status, and how to interpret that. Before we go to the questions, if you're interested in the slides, you're going to find them, well, you can actually find them right now on histexo.github.io/CephTechTalkPG. Those are the rendered slides. If you're looking at the source code for those, and that's at github.org/histexo Ceph Tech Talk PG, and all my slides are always under a Creative Commons Attribution Share Alike license, so please feel free to use them as you wish. And if you would like to know what I and my company are doing about Ceph, you Ceph landing page. That's www.astexo.com/Ceph. And with that, Patrick, I'll be happy to open it for questions.
Yes, if you have questions, feel free to either type them in the chat or unmute your microphone and ask them as well. The only thing that I might add to Florian's talk is we also have a handy-dandy placement group calculator on the Ceph.com site that if you're looking to build a new Ceph cluster or expand it, you should definitely take a look at that, and it will help give you an idea of how many placement groups your cluster might need. And I'm pasting that link in the chat.
Exactly. That's at ceph.com/pgcalc. That's very, very useful. And thanks for that input, Patrick. That's something that you absolutely should look into if you are building a new Ceph cluster or in order to verify the PG configuration of an existing Ceph cluster.
Yep. Looks like we have a question from Abhishek, who's asking if during a write, if a client has a newer map than what an OSD does the write fail, or is there a redirect from the OSD?
So it's an excellent question, and basically, let me rephrase that. It basically boils down to, so how is the map actually propagated, and how do clients and other servers actually find out about that? And this is one of the things where I think Ceph is very simple yet elegant. The way this is done is that the OSD map, you may have picked up on that when I previously did the Ceph OSD map command. The OSD map is versioned with an incrementing integer ID called the map epoch. And what happens is that all client to OSD and OSD to OSD communications are simply signed, or well, actually not signed, they're tagged with that epoch. And so what happens is if a client talks to an OSD or talks to any other component, it does so with a tag message that has the map epoch in it, and the other OSD can then say, all right, you're actually slightly behind. Here's the new map. The new map epoch is X. And by the way, here's the new map, or here's the map update. And then the client can appropriately redirect. And that is effectively the lazy propagation of the map that I mentioned earlier, which is actually a really, really nice and handy feature in Ceph because it completely does away with any requirement to actually propagate the map out in a push fashion. Abhishek, if you could just confirm that we've answered your question in the chat, that would be great. Perfect. All right.
Next question here from Eric, saying we've had issues with incomplete PGs, which had to be fixed by increasing the iterations, but that was a guess. It says there's an easy way to know if you need more iterations.
Eric, could you please clarify which iterations exactly you're referring to? And in the meantime, I am going on to the next question. If you're using a cache tier and you run into the lost OSD, will it know to check cache to see if it was hot or non-dirty PG and recover from that? Greg, if you could, I would like to come back to that question separately. If you don't mind, you can certainly shoot me an email. It was in the first slide, and my email address is florian@astexo.com, and I'll be happy to come back to you on that one. It was a change in the crush map. Okay, so Eric, would you mind unmuting your mic for just a moment and explain to us exactly how you ran into that situation?
Sure. Well, Eric's working with his mic. Does anyone else have any other questions?
And I'm sorry, just by the way, Eric, for you, the same thing applies. If you want to just shoot me an email to florian@astexo.com, then I'll be happy to look into it that way. So the question, when a client request has already reached a primary PG, and at that moment the PG or OSD dies, what happens? Is that a degraded write? That's another really good question. And it basically boils down to, again, let me rephrase that, how synchronous is the replication to an OSD? A client write is only acknowledged by the primary OSD if it has reached at least the OSD journal on both the primary OSD and replicas. So in other words, if a write reaches a primary PG and does not reach replica, then the primary, if the write reaches a primary OSD and the primary OSD cannot replicate on to a replica, then as far as the client is concerned, that write never completes. And if the primary happens to go down, then the client redirects that write. If it is the primary detecting that a replica goes down, then it will effectively, well, at that point, the PG is going to be degraded, and it's going to write just to the alive replicas, unless, of course, again, we are now under the min size, in which case the write will fail.
Cool.
So that's basically the consequence of there being synchronous replication from primary to replica OSDs. And yes, if a write fails, and it's the client's job to retry the write. Yeah, I'm sorry. If the primary fails, then it's the client's job to retry the write. Yeah.
Yep. Okay. Looks like Eric's microphone just came off mute. Eric, are you there?
I am. Can you hear me?
Yep.
Yes.
Perfect. The issue we had was we were dealing with recovery from some failures, and basically I was getting incomplete PGs, and more or less there was a setting in the crush tunables for how many times to try, and finally I just cranked that number up to like 100, and all of a sudden my incompletes went away. So I was assuming that the algorithm was such that I didn't give it enough choices in the standard. I think it's 50 tries. But that was a guess of why it was failing. There was no real good indication of why it was giving me the incomplete.
Okay, I'm afraid that that's a question that's a little bit too specific for the tech talk, because I'm not sure if it's that immediately interesting to the rest of the audience. But like I said, I'll be happy to look into that, and I actually have a couple of follow-on questions to that, and as to how the situation came about. So again, if I could ask you to just shoot me an email at florian@hystexa.com, I'll be happy to look into it.
Will do. Thanks.
Okay.
All right. Thanks, Eric. The next question here from Brian. When you do a Ceph PG repair, how do you prevent it from replicating the corrupted data to other PGs?
So the information that is being checked by a Ceph PG scrub and a Ceph and a deep scrub is basically information that's stored in encoded form in the OSD itself. I'm actually not entirely sure if that is something that the OSD still puts into file attributes, because a couple of releases back, pretty much everything moved to OMAP. Patrick, you might actually have more information about that than I do, but the basic idea is that you have a separate set of metadata where you're keeping hashes of the data that you're trying to look for. That's how you detect which one is actually the good data set and which one is the bad data set, and that information you can then simply use that information Ceph can simply use when you repair. So it's the scrub or the deep scrub that actually detects which is the data set that's good and which is the data set that's bad, and then a Ceph PG repair simply operates based on that information.
Okay. Are there any other questions while we have Florian here on placement groups? All right, I think that's an appropriate amount of time for someone to type out their question. So looks like we are all finished here. Thank you very much, Florian, for a great overview of placement groups. I get many questions on what those are and how to use them and how to plan for them. Once again, if you're looking for more information or more specific ideas on how to use placement groups for your cluster, definitely check out ceph.com/pgcalc. It's a very helpful resource, or you are welcome to ask questions on the mailing list or IRC. So this was a great talk, and I will see you guys all next month for the next Tech Talk.
Thanks, Patrick. Thanks, everybody, and have a good one. Bye-bye.